Hi there. This video is about the effect of a change in temperature on the volume of gas. Let's begin. It is a matter of common observation that when an inflated balloon is kept in a warmer surrounding air, say near to the stove, its size increases. Say this was the initial size of the balloon, and when it is kept in a relatively warmer air, its size increases. And similarly, when the balloon is kept in a relatively colder surrounding air, say in fridge, it loses its size and tightness too and becomes flaccid. So from this common observation, it can be concluded that gases expand on heating and contract on cooling. The phenomenon is called thermal expansion and thermal contraction, respectively. Thermal expansion happens on heating a gas, whereas thermal contraction, it happens on cooling a gas. By using these observations, Charles in 1787 proposed a law which is called as Charles' law, and it explains the effect of a change in temperature on the volume of gases. Let us look at this figure. It is actually Charles' law apparatus. Here we can see this is a capillary tube with the uniform bore. This is the air entrapped in with the help of a mercury drop. This is a mercury drop. This end of the capillary tube is sealed. So when a mercury drop is added from the open end of capillary tube with the uniform bore, it entraps some volume of air in it. Say before heating, this was the volume of entrapped air, and after heating, the new volume is this much. This thing is water bath. This is beaker, and this guy here is a thermometer, which is used to measure the initial and final temperatures and to determine the increase in temperature on heating. So when heat is supplied to the system, water molecules in the water bath, they absorb thermal energy, and in turn they transfer their heat energy to the molecules of entrapped air in the capillary tube. The molecules of air, after absorbing thermal energy, undergo increase in their average kinetic energy, and because of that, collisions between air molecules become more energetic. As a result of this, collision frequency also increases. It results in the increase in pressure of the trapped air higher than the external pressure, which is the atmospheric pressure, since the upper end of a capillary tube is open. So external pressure is constant, which is equal to 1 atmosphere. So on heating, the pressure of trapped air increases than the normal pressure. Therefore, the mercury drop that acts as some sort of a piston is pushed upward until the pressure of trapped air, which is gas, that gets equal to the atmospheric pressure. Consequently, the gas expands on heating. Opposite happens when the system is cooled, or when the gas is cooled. So let us see what is actually happening when we heat the gas, or when we increase the temperature. On increasing temperature, average kinetic energy of the gas molecules increases. Collisions between particles of gas become more energetic. As a result of this, collision frequency increases. Collision frequency is actually the number of collisions made among the gas molecules per unit volume of gas per unit time. As a result of this, the pressure of entrapped air, means the pressure of gas, it becomes higher than the external or atmospheric pressure. Due to this, mercury drop that acts as some sort of piston is pushed upward until the pressure of gas, that becomes exactly equal to the pressure of applied over the gas, that is atmospheric pressure. So as a result of this, volume of gas increases. Opposite happens when the gas is cooled or when the temperature of gas is decreased. Using these observations, Jacques Charles proposed a law which is called as Charles law in 1787. Now let us look at this figure. Say this is the constant external pressure P, that can be atmospheric pressure or any applied pressure, and this is a gas with the n number of moles of gas. Both the number of moles and the pressure are the constants for Charles law. Now let this initial state of the system when the temperature of gas was T1 and its volume was V1. On heating the gas, the temperature changed to T2 from T1 and the volume expanded from V1 to V2. This is the initial state or initial condition of the gas, that is before the change had happened, and this is the final state or final condition of the gas after the change has taken place. So from this observation, it can be written that volume of gas is directly proportional to absolute temperature when number of moles and pressure are constant. This is the statement of Charles law. Now let us write the statement of the law. Charles law states that volume of given moles of a gas is directly proportional to absolute temperature if the pressure is kept constant. Temperature in degrees centigrade can be converted into Kelvin scale by adding 273, or to be more precise, by adding 273.15. Charles law holds only when the temperature is in kelvins. Now from this relationship we can write that volume equals K times absolute temperature, where K is the proportionality constant, V is the volume of gas, and T is absolute temperature. On further rearranging, we get this ratio, that is V upon T is equal to K. This equation gives another statement of Charles law, and that is ratio of volume of gas to its absolute temperature is always a constant quantity provided the pressure is kept constant. Now this law can also be explained graphically by plotting of graph of volume versus absolute temperature or temperature in degrees centigrade, taking volume of gas along y-axis and temperature in degrees centigrade on x-axis. Straight line graph is obtained, which indicates that on increasing temperature, volume of gas increases, means gases undergo thermal expansion when they are heated. For example, let the initial temperature of gas was this one, that is T1 degree centigrade, and at this temperature and constant pressure the gas was occupying V1 volume. When the gas was heated, temperature increased from T1 to T2, gas expanded, and at the final temperature the volume of gas was V2. It indicates that increase in temperature increases the volume of gas. If you liked the video, please do subscribe my channel and hit the bell icon so that upcoming video lecture on chemistry may not be missed. Sharing is requested too. Thanks for watching.